Okay, so hello everyone. In this video, we will cover ARP and NAT. So, in this video, we will discuss ARP, which is Address Resolution Protocol, and NAT, which is Network Address Translation. So, I am going to explain ARP. First of all, I am going to explain ARP, that is Address Resolution Protocol. We have to do resolution of the address. It is that we are converting logical address into physical addresses here. ARP is the protocol of layer 3. So, this converts IP address into MAC address. Okay, let me clear all the scenarios to you with an example. Let's say this is a network. This is a network 1. Let's say in network 1, A wants to communicate with C. A wants to send a message to C. So A can have the IP address of C. How will it have the IP address? Because it's public. So you will get the IP address of C. But even if it doesn't get it, if it doesn't get the IP address of C, it can actually take it from the default gateway. Okay, so A is connected to the default gateway. Now when A wants to communicate with C, the IP address is there, but is communication possible without MAC address? No, communication is not possible. Okay, because you need MAC address in LAN. Now what is the MAC address? It is a physical address, the 48-bit address on the NIC card, which is not public. How will A get this address? Let's say A has to send some message. A will first find C's MAC address, and then A will start the communication. So A will first enter the IP address of source. It entered its IP address A. It entered its MAC address also. That's my MAC address is A. Now it's of 48. MAC address is of 48 bits, and IP address is of 32 bits in IPv4. And along with that, in destination, what is the destination? C is the destination. Okay, it entered the IP address of C, but it doesn't know the MAC address of C yet. So in this case, since MAC address of C is we don't know, by default here this message will be send it to all. So it actually does all F. All F means the actual broadcast message of 48 bits. So the request of ARP is always a broadcast message. That's why if you write FFF, like this time 12 times F for 48 bits, this will be broadcasted. So this message will be sent to the switch, and it will send to everyone. When C receives this packet, it will know that there is my IP, there is C's IP we have added in this packet. So means someone wants to communicate with me. Okay, C will notice that someone wants to communicate with me, so it will reply. Then when it replies, the reply is always unicasted. It is just like you are going in a class and asking who is Akshat here. So you ask to all, means your message is given to all the 100 students sitting in the class, but only Akshat will stood up. What is meant by this request? This request was broadcasted, but reply was unicast. Just for example, assuming there is only one Akshat in the class, because MAC address is unique. Okay, it's always unique. So now C will respond in a unicast way. This is the communication. Okay, there can be 4 different cases. Let's say if there is a host and it wants to communicate with the host, this is one case. Host want to communicate with router, means with gateway. It wants to communicate with default gateway. So let's say A want to communicate with the default gate. What will be the reason for that? Maybe A want to communicate with Z in another network. Okay, which is in some another network. Okay, in that case you will have to go out of the network. So you know that you have the IP address of Z, because the IP address tells you the location, but the MAC address is the address of that machine. So in that case, A will first enter IP address of default gateway, but it doesn't have the MAC address yet. So A first send it a broadcast with its MAC address. Okay, and when it gets the MAC address, it has to send it to forward. So what it will do? It doesn't have Z's MAC address. IP address is there, so it will enter its own IP address, MAC address, and Z's IP address and send that. Okay, send that packet. Since it doesn't have Z's MAC address, it will broadcast again and reply will come. There are 4 cases. First is host to host, second is host to router, third is router to host, and fourth one is router to router. In these 4 communication can be done. Now finally, if we talk about the header information, hardware type is a field of 16 bits. If we are using Ethernet, so the type of Ethernet is 1. So in that case we will input Ethernet type as 1. Then if we talk about protocol type, this is also field of 16 bits. Okay, which protocol? Either you are using IPv4, IPv6. If you are using IPv4, then 0800. This is the hexadecimal value of this. Okay, this field. Then hardware length means the hardware you are communicating with, its length. Hardware length means the MAC address of the hardware. Let's say normally if we talk about MAC address, obviously it is of 48 bits, which we represent with 6 bytes. Okay, so hardware length, if you are talking about Ethernet, in case of Ethernet we will put value of 6 here. Now protocol length, it is a IPv4, so its value will be 4. Value of length will be 4. Operation, if you are requesting, then its value is 1. If you are replying, then its value is 2. Then the same story, source will enter its hardware address, Ethernet address of 6 bytes. Source will enter its IP address. In case of IPv4 of 4 bytes means 32 bits. Okay, now in target field, we don't know the target hardware address. To all that we will enter all F, okay, 12F here for the broadcast address, for the broadcast. So this is the whole story of ARP. Now moving forward to NAT, network address translation. What is network address translation? The actual use of NAT is for this network. Now which IP address is translated into which one? Remember this simple point: it translates private IP to public IP and the public IP to private IP. See, you can imagine a simple scenario. Let's say there is a university and there are 10 hostels, okay. In that university 10 hostels are there. If you see, in every hostel, if I give every room different room number, means if I given a room number 101 in one hostel, can I give 101 to another hostel? Yes, obviously I can, okay. Can I give 201 in other hostel? Yes, I can, okay. Can I give 201 in third hostel? Yes, I can. What is mean by this is that if we talk about the room numbers within the hostel, that should be different. But if we talk about two or four more hostels, room number can be same, okay. Meaning if 101 in hostel number 1, then it can be in hostel number 2 also. Even if we talk about hostels, there are thousands and lakhs of hostels in the world. In every hotel there will be the number of room like 101, 201. In today's world we need a dedicated IP address. Means we aren't working on one machine, okay. We are working on 3 4 machine, okay. I need different IP address on every machine. If I want to use this much of IP address, there are so many private networks, each wants a dedicated IP. So how will I provide this much of IP address? Because in IPv4 we use IP address of 32 bits, so total of 2 to the power 32 IP address are possible. So actually NAT made it scenario easy. If we talk about IPv4, I'm not talking about IPv6 here. And in classful addressing we made 3 ranges: one of 10.0.0.0 oblique 8 in class A, and 172.16.0.0 in class B, and 192.160.0.0 16 in class C. So what will happen now? If an organization says that I need this much of IP addresses, then I will not give them all the public IP address. If I will give all the public IP address, then my total number of IP address will get restricted. So what will we do? We will assign private IP addresses. Like if I take an example of this college university, so we have gave them a 10.10 IP address from the first range. So it internally made host like 10.10.0.1, 10.10.0.2, like 0.3 and 0.4. It made these multiple hosts. It made its private network. This private network means if we talk about 10.10.0.1, this same can be allotted to some another university, okay. There is no problem in that. Why? Because we are using this privately within this organization, okay. So you can use the same address in different universities or college or organizations, because it become a private network now what will happen? The outer world, the internet, doesn't know that what is inside this organization, okay. Internet has nothing to do with this. Internet will get to know my organization by public IP, okay. So let's say this is the public IP of my organization, 125.12.31.7, and let's say corresponding to that I have also taken a domain name xyz. Now what will happen? The whole world knows me by this IP address. Let's say here is my host 10.10.0.2, okay. It says that I want to use Facebook or Gmail or any other web page from the outer world. So the packet that will be generated will have its own source address, okay, because it is generated by itself. What will be the destination? Let's say it want to access some website. Let's take this address like 25.25.25.10. let's say it want to get there and access this particular host. Now what will happen? This is the source address and this is the destination address, okay. So when this packet will reach the net, it will change this source address. Means the packet it will receive, in that packet it will change the source address and will paste the public source address, okay, because the outer world knows by this. So it will make its source destination, okay. Now destination is already told by that, like that I want to access this host, okay. So this packet will go out and it will go to the that particular host, okay. And then whenever the web page or whatever it wants to access, when reply will be received after accessing, in that case when reply will come to this host, the server in the outer world will make the source address its own address. This address will become source address and destination will become the IP address. When the packet will reach here, I have to take the packet to the end also. Till this place NAT will again do the translation. Means if I translate private means I translate private IP to public IP, now it will again translate public IP to private IP, okay. So for that it is using translation tables, because when the packet will return, where it has to be sent, that is also necessarily to remember, okay. Now when the packet is going out, it made an entry 10.10.0.2 has to access 25.25.25.10. Okay, it has to access that. Okay, so the packet went out. Now when the packet will return, this one will be written in the source, so it will make the destination this one. That's how the communication will done. Okay, it may be possible that you will think that in a host multiple application are using the same IP address, so there can be multiple connection corresponding to that one IP. Okay, so to resolve that, later on along with the private IP port, private IP, we have introduced port number. Like you can make entries like this: private IP, private port, public IP, public port. The main story of NAT is that it works like this: public IP to private IP and private IP to public IP, so that we can use our IP addresses properly. But later on, now NAT is also not needed as much because IPv6 we have introduced. Okay, in IPv6 there are 2 raised to power of 128 IP addresses. So in that, if we don't use this, then also it can work, because there are so many IP addresses that won't like end soon. Okay, so that was whole concept about ARP and NAT, address resolution protocol and network address translation. Okay, so that's it for this video. We will meet in next video. Until then, bye bye.